and welcome to another session of e-learning. Today we'll be looking at vectors. First thing, definition of a vector. A vector is a quantity that has size or magnitude and direction. Now, we look at some examples of vectors. Examples such as force and velocity. Likewise, we have scalar. Scalar quantities has only magnitude or size. Now let us look at how we can represent a vector. A vector can be represented using a straight line. So let's say we have a straight line on a graph. Now let's say we have a graph like this, and it says A to B. Note A coordinates here is 1 and 2, and B here is 4 and 4. Now this vector A is a displacement that is moving from A to B. The arrow shows you the direction that it is going from A to B. So this vector A to AB can be written as, normally we write it as a column vector, which means how many you're doing how many rows for us, so it's how many x's, so it's 3 across and 2 up. And you can do it by showing you go 1, 2, 3 across, and how many up? 1, 2. So AB is 3, 2. Note we show the arrow above to represent it moving from A to B, and it's written in column form vector here, 3 to 2. Now sometimes you can use a small letter, like you use say A here, and it's written in bold, and that can represent also a vector. Just give it the name A and say the vector A here. Now one other thing you must always know how to do is to calculate here the length of a vector. How do we find the length or the length of this line? Now we use Pythagoras theorem. For those of you remember what is Pythagoras theorem, so the length of a line of a vector, which is written as, say we want to find the length of A, and then we'll write it in here like that. That's it. The 2 sign is called the modulus. So if you want to find the modulus or the length of the line, we use Pythagoras theorem by saying, which is square root of x squared plus y squared. What that means, it is, note x is first and y is the second. So x is above and y is second. So that is 3 squared plus 4 squared, which is the square root of 9 plus 16. Sorry, 2 squared here. Square root of 9 plus 4 is equal to square root of 13. So the length of this line here, we will use square root of x squared plus y squared to find the length. And here it is the square root of 13. Now, vectors can be added and subtracted. How do we add vectors? Simple. Let's say we have a vector 4 and 2, and let's say to add 3 and negative 4. Right? What we do, we add each component here. So we add the x with the x and the y with the y. So here it becomes 4 plus 3 is 7, and 2 plus negative 4 is negative 2. Alright? Likewise, we're going to add, if you subtract, it's the same thing. Let's say we have 4 and 2. This time we're subtracting 3 and negative 4. Same thing. You see 4 minus 3 is 1. And 2 minus negative 4, that becomes 6. As 2 negative here is a positive. So here, what we normally do, to add and subtract vectors, we add the x's and we add the y's. 2x add together, the 2y add together. Likewise, subtraction, subtract the 2y's, the x, sorry, and subtract the 2y's. Now one of the things you must know in vectors is when we have two vectors and you want to combine them, right? And I'll show you graphically how to do it on a graph. If we have a graph, and I'll also show you also when we work it out. So, now if you look at this here, we have here a vector O, no, origin here, this is the origin. We have a vector OA, then we have a vector OB, and then when you combine them, you have A to B. Now look at how the relationship is. Now we know vector showing you, if you follow the graph, if you follow the direction here, OA plus, OA plus AB will give me OB. If you follow the direction OA, as in go in this direction, plus AB will give me this OB. Now, you can look at it a different way also. Let's say the way I normally would do it, let's say they ask you to find what is AB. So you're at A here and you want to get to B. Note, normally they give you OA and they give you OB. So what we'll do, we always try to go back to the origin. So what I normally do when I do these questions, right? If I want AB, I will start with A, knowing I want A first, and then I'm going to the origin O, plus, then I'm from the origin back to B. So it's most what you realize is the two in the middle must be the same. So the O, origin in the middle, so when you cancel it out, you'll see it's actually AB. But note, what we're doing here, we are going from A to O. But they give us is O to A. Now, you must realize there's a relationship between OA and AO. The relationship is, if OA is going this way, AO is in the opposite direction. So OA, the relationship is negative OA is AO. Negative OA, so because you go in the opposite direction, you have to change the sign for what the coordinates they will give you. And I'll give you an example, a work example for that. So the negative OA, right, represents AO. Because you go, note OA goes this way and AO goes the opposite direction. So it becomes a negative. And I'll go let me show you, give you an example for that. Also note here, because we started from the origin, OA and OB, these are what we call positional vectors because we started from the origin. So vectors that start from the origin are called positional vectors. Now let us look at an example. We work an example together. Let's say the question says OA and OB are position vectors relative to the origin O. Given the points A, so A is equal to 3 and 1, and B is equal to -1 and -2. Right? The first question says, write down OA and OB as a column vector. Then they want us to express AB as a column vector, and part C says calculate the length of AB. So what I normally do first, I normally do a sketch of what they give us. So one, two, three, 1, 2. So A here, they say is 3, 1. So it is 3 across an X and 1 up. So point here, and it will start from the origin. So it goes like this. So this is basically A. But we will label it as OA, because what we did is start from the origin to A. So that's why origin to A is called OA. Then the next point is B, negative 1. If you want some points over here, negative 1, negative 2. Right, so negative 1, which is here, negative 2, which is right down here. So this is B, and this is called OB. Because we're moving from the origin to B. Now the first question says write down OA as column vectors. So OA as a column vector. It's just telling you how many across, 3 across, and how many up, 1. So that's just the answer as a column vector. When you're writing it like this down, it's a column vector. And then OB is the same thing. Negative 1 across. When you go to your left, it becomes negative, and negative 2, and 2 down, negative 2. So that's the answer here. Now, the next question says, express, you want to find AB. Find AB and write it as a column vector. AB as a column vector. Look at what, let's go through it. So here, we know what is OA, we know what is OB. They want us to find A to B. So here, to connect, so from A to B, which is in this direction, A to B. So what I normally do, I want to find AB. I am say you're standing at A and you want to get to B. So what we'll do, instead of going on the straight line, because we can't just take the straight line, we'll go from A to O. So we get from A back to the origin, plus, then we go from the origin to B. Origin to B. So we see here, the two in the origin here, both of them are in the middle, so we have the A, B. If you understand that. Now, look at, we said just earlier that OA, the negative of OA is AO, the negative. So that means if I have OA, the coordinates for OA was 3 and 1. If I want AO now, AO, the opposite, it is the negative of these here, so it becomes negative 3, negative 1. So the opposite, it changes the sign of, because they go in a different direction. Because they go in a different direction, it changes the sign. So this here becomes, AO is negative 3, negative 1, plus, now OB didn't change the direction because it's going in O to B. So you write back the same OB, negative 1, negative 2. And when you add them now, negative 1 plus negative 3 is negative 4. Negative 1 plus negative 2 is negative 3. So this here is AB, negative 4 and negative 3. Now they ask us now to, the next question says to calculate the length of AB. How long is this line, A to B? We use the Pythagoras theorem as we said earlier. So we said AB, the length of AB is equal to the square root of negative 4 squared plus negative 3 squared. That gives me the square root of 16 plus 9 is equal to the square root of 25, which is 5. So the length of AB is 5. So that explains to you how the relationship. So if you have OA and you have OB and we want to find from A to B, we always know, what I normally do is that if I'm standing at A and I want to get to B, we always go back to the origin. Now there's different ways you can do it. You can do it also by doing, you can say OB, subtract OA, right? So, but because I like to add, I normally use it. And because I want to do from A to B, I like to say I'm starting at A and I want to get to B. So if I travel, you only know these two lines. You know this and you know that. You don't know the coordinates for this. So use what they give you. I am at A and I want to get back to B. So I start A, I go back to the origin, because the starting point, then from the starting point to the B. So I'm reaching here now. So if you do that, you'll see you get AO plus OB, and you get your answer. Now we're going to get onto something here, vectors and how it's used in geometry. I'm going to give you some walk-in, some examples, and you'll go through it. You may see a lot of these on your past paper questions for CXC, and it's very important that you understand and know how to do them. Now let's say we have I'm going to give you a parallelogram, and so I'm drawing a parallelogram on it here. We have A, B, C, and D. Okay, so this question says, in the parallelogram shown, AB is equal to B, this is bold, this is a vector, and AD is equal to D. Also, X here represents the midpoint of B and C. And Y lies on DC such that DY is equal to 2CY. So that means if this is 1, this is 2, because it's 2 times of what this is. Okay? Now these are the kind of questions you get in CXC. It says express the following vectors in terms of B and D. So let's see, they wanted to find AC in terms of these two, B and D. Now if we want to find AC, so we are standing at A and we want to get to C. Here they didn't give you no coordinates, they just said to express it in terms of B and D. Also in parallelogram, the opposite sides here are equal. So this and this is equal, and this side is equal. Alright? So if I want to get to A to C, what I would have to do is I have to travel from A to B. So I'm going from A to B plus from B to C. So A to B, then I'm going now from B up to C. Again, you can see both in the middle are the same, so I'm getting A to C. Now, A to B is a vector what? B. A to B. Plus B to C, B to C. What is the vector here? Because the vector over here, A to D, is D. It's the same vector over here, D, because these two sides are equal. So D is over here also, so this is just the answer. B plus D. So it says express it in terms of B and D. So if I want to get from A to C, it is B, vector B plus vector D. Okay, let's look at one more. We have BX. So we want BX. So that is, I only want here from B to X. Note, it says X here is a midpoint. It is a midpoint. Midpoint means it's halfway. So because X is halfway of BC, X is the half of BC. That is what X is. So BX is half of BC, right? We know that BC is the same thing as D, so it's just half of D. BC is D, because if we want to put it in, you see here, if this is D, over here is D. That is, the vector is D. No, this is X is different. If this is B, this up here is B, and it will go in that direction, the same direction also, right? Same direction, this direction, so this direction up. Let us look at for AX. AX. I am standing at A, and I need to get to X. So I am traveling now from A to B, so A to B, plus I'm going now from B to X, B to X. As you can see here, both in the middle same, so I'm getting A to X. When we do that, a to b is small b, plus b to x, we say we got that already, b to x was a half of d, and that is your answer. It's just expressing them in terms of b and d. We mean you only want b and d in your answers. Let's look at dy now. Let's look at another. Hope you understand what we're doing. Let's say we have d to y. So we are here at d, and we want to get to y. Note dy, it says dy is equal to 2 of cy. Right? Dy is equal to 2 of cy. So if we want to find dy is equal to, basically, if this is 2, as I said, this is 1. So dy is, and if you add 2 and 1, so it's like splitting it 2/3 and 1/3. So dy is 2/3 of dc. Because dy is 2/3 of dc, which becomes 2/3 of b. Because dc is b. Same b here. Let's say we want to find ay now. Ay. So we have a, and we want to get to y. Right? We have a, and we want to get to y. So we can do it this way. We can say a to d. So you're going from a to d, plus from d to y. D to y. So a to d is d, plus dy we got was 2/3 b. And one last question. If we want x to y, if we want we are standing at x, we leave here and we want to get to y. X to y. Now we can do from x to c. So we're going from x to c, and then from c to y. And you see what, so we're going from x to c, and then c to y. Now x to c, we look at the direction, it's following the same direction as the arrow, and it is half, so it is half, because x is in the midpoint, so it becomes half of d. Plus, note that what happens here. Now we're going from c to y. Note so we're going in this direction, in the opposite direction of the b. So if it was y to c, it would have been, this is 1, so it would have been 1/3. So y to c would have been 1/3 of b, because it would have gone this direction from y to c. But note, we are going from c to y, which is c to y. So we're going in the opposite direction, so it becomes -1/3 of b, because we're going in this direction. So this here becomes a half of d plus, if you want to put it, -1/3 b, which is the same thing as writing it as a half of d minus 1/3 b, because the plus and the minus here. We understand those questions I give and that I walk through. We'll do one more set of these questions for today. Again, let us look at another parallelogram. Another parallelogram. And these are the popular set of questions. You must understand them, follow what you're doing. If you have any questions, feel free to contact. So if we have another parallelogram, this is O, A, B, and C. And this is represented by small a, this is represented by small c. Note they are bold. And this is the diagram shows the parallelogram O, A, B, and C. O, A, B, and C. Where OA is equal to A, and OC is equal to C. Write the following vectors in terms of A and C. So the first vector we want is, how do we find AB? What is vector AB? Now, that's very simple. AB, you're going from A to B, the same direction here. And as I said, parallelogram have opposite sides are equal. So if this is C here, this is C also. So the answer is just C, because it's the same vector OC, the same as the vector AB. The next one says, what is vector CB? Vector CB is the same thing as vector OA. So you go in the same direction, which is up, and the same, which is A. Then BC. Again, BC now. Now B to C. All they're doing is the opposite direction. It's going in the opposite direction. If from C to B gives me A, from B to C now will give me negative A. Just opposite direction. So because the opposite direction, the sign will change. Then we have A to C. So we have A here, and we want to get to C. So you can go A, you can go two ways. You can go A to O, A to O. So A back to the O here, and then O to C. Right? See, both O's in the middle, and what you want is AC, and they're at the end, A and the C. Note AO means you're going in the opposite direction of what the arrow is going. The arrow is going in this direction, so AO will go in the opposite direction, so it becomes negative of negative A, plus OC is in this direction, which is C. Correct direction, so negative A plus C. When you do two more, we want to find OB. So we want to get from O here up to B. You can go very simple. We go from O to A plus from A to B. Again, you see the two in the middle are the same, so O to A, O to B, which is what we want. O to A is A, plus A to B is the same C, so just A plus C. And the last one, which is CA. So we're at C, and we want to get to A. Let us do it. We could do it either way. We can see we can get from C to O, and then O to B. O to A. C to O is going in the opposite direction of the vector. So it becomes negative C plus O to A is the correct direction, which is A. And that's your answer. Now, if you have any other questions based on vectors, feel free to contact, and I'll be glad to go through them with you. Thank you for today.